Probably an engineer's most important job is to document their results in a report or presentation so that other people can act on their recommendations. More often than not, the most important part of any report or presentation are the figures in the report. They tell your story in a way nothing else can. A well-presented figure can make a report, and a poor one can ruin it. Matlab can help you make really good figures. In the last video, I introduced Matlab's basic graphing capabilities. That video likely covered most of what you need in order to create good two-dimensional plots, but probably not great plots. For example, Matlab has lots of types of plots that it can create beyond the typical XY plots I did in the last video. It can be helpful to put multiple plots in a single figure window. There are also a lot of options for customizing your plots. These can make your plots a lot easier to understand and read. Finally, being able to add numbers to your plot annotations can speed up your creation of plots tremendously. First, I'll discuss some of the other plot types that Matlab will create. There are lots of options, such as log plots, semi-log plots, pie charts, histograms, and so on. Matlab's documentation will show you what plot types are supported and how to use them. So I'm just going to show you where the documentation can be found. To open the basic help screen, type DOC at the command prompt and press enter. Click on Matlab and then select Graphics. Different plot types are discussed at the 2D and 3D plots link. You can browse around here to see how to create the type of plot that you want. As I said, most of these work in about the same way, so if you can use the plot command, you can probably use any of the other plotting functions. Now I'm going to talk about putting multiple plots in a single figure window. This can be really useful if you need to present plots that will all be compared to one another. The important command here is the subplot function. Any of our previous commands for applying titles, labels, and so on still apply when we create plots using the subplot function. The general syntax of the subplot command is the function name, subplot, and three arguments, m, n, and p. M and n define the size of the grid of plots that will be created. The grid has m rows and n columns. P tells us which plot within this grid you want to activate. To determine the value of P for any section of the grid, start counting in the upper left corner of the grid. Count from left to right. When you get to the far right side of the row, move to the next column and continue counting from left to right. Let's look at an example of what I'm talking about. The example is the command subplot of 2, 3, 5. This command creates a grid of plots which has 2 rows and 3 columns. The plot numbers are 1, 2, 3 in the first row. Then we go to the second row, 4, 5, and 6. So the fifth plot's here. This command creates this figure, if it isn't already created, and activates this plot in the lower center section of the grid. Any subsequent plot-related commands, such as plot, title, xlabel, and so on, will be applied to this plot. Now I'll demonstrate this example in Matlab. For this exercise, I'm going to recreate the data we were working with in the previous video. We had a time vector t equals 0, 0.01, 10. We created a y vector, y equals 3 times exp of minus t over 2 dot times cosine of 4 times t. And a z vector, z equals 5 times t dot times exp of minus t. Now to create a figure to work with, type figure and press enter. We get a new blank figure window. Now type subplot of 2, 3, 5 and press enter. The figure window is now subdivided into a grid, and the lower center section of the grid is activated. To plot in that section, just use the plot command as before. For example, plot of t, z. Titles and labels also get applied to that section of the figure. So let's add a title, a subplot, and add a label to the x-axis with the xLabel command. Make that time. Now this section of the figure window remains active until you change it. To move to a new point in the grid, use the subplot command again. So let's type subplot 2, 3, 3, and then add a plot to that section by typing plot t, y. Now we've added that plot to that section of the grid of our subplot. In this section, I'll show you how to further customize your plots. I've already shown how to change the color and style of the line and how to add symbols to the plots. You can also use the plot command to do things like change the line width, color in the symbols, set the axis ranges and labels, and so on. First, I'll pretend that I have some data which corresponds to the function y of t. I'll create this by using a different time scale and adding some noise to the function so that it all doesn't look like it's exactly on the line. So let me create a new time vector, t data equals 0, increment by 0.1, and still go to 10. Now I'll create my y data equals 3 times exp of minus t data over 2 dot times cosine of 4 times t data plus some noise. My noise will be 0.5 times, and I'll create a set of random numbers with the randn command. The argument to that is going to be the size of t data. Now I'll plot the data. Type plot of t data, y data, comma, I'll put little circles, red circles at the data points, quote, R, O, end quote, comma. Now on top of that, I'll plot the line itself, t, y, comma, quote, k dash, end quote, to make a black solid line, and close the parentheses. There's our plots. I can add a legend to this by typing legend of, quote, data, end quote, comma, quote, function, end quote, close parentheses. So far I haven't done anything new. We've just used commands we presented in the last video. Suppose though that I want to fill in the faces of the symbols on my data and make the line representing my function wider. I can use what are called name pair arguments to do this. There are name pair arguments for the line styles and markers I've been using. It's just easier to use the shorthand that we introduced earlier. You can find some of these arguments on the plot command help page. To see that, let's type doc plot. About 2/3 of the way down the page, we have the information we need. Now to plot the data with a green face color on the symbol markers, type plot of t data, y data, comma, R, O to get the little red zeros, a quote, marker face color, end quote, a comma, another quote, and the code for green, a G. then close the second quote. To plot the function, but with a wider line, type plot of t, comma y, comma k dash. We still want a black solid line. Quote, line width, to change the line width, a comma, and the line width we want. I'll choose a 2. Notice that when I changed the face color of the markers, the code was a string and was in single quotes. When I changed the line width, the code was a number and required no quotes. These codes can get a bit tricky if you try to plot multiple sets of data within the same plot command. So if you want to do this, I'd recommend plotting each data set individually and using the hold command to overlay them. To illustrate this, I'll first clear the figure. Now I'll use the up arrow on my keyboard to plot the first data set. Then I'll type hold on and use the up arrow to plot the second data set. You can customize the axes on your plots with the axis command. The command is axis. The argument to the function is an array containing the minimum x value, the maximum x value, the minimum y value, and the maximum y value in that order. So to change my axes, I'll type axis and open parentheses and open square bracket to denote that I'm inputting an array, and the range on my x and y axes. My minimum x will be -1, the maximum x will be 11, my minimum y will be -5, and I'll choose my maximum y to be 7. Now close the square brackets and close the parentheses. Let's look at our plot. My choice of axes is probably worse than what Matlab defaulted to, but the point is that I can change the axes if I want. I could also change the tick marks on the axes and their labels with the x tick, y tick, x tick label, and y tick label options. I'm not going to demo those options. If you have the urge to use them, just search Matlab's help for how to use them. Type doc axis. Axis properties is a link at the bottom of this page. This link will tell you more than you probably ever want to know about setting the properties of your axes. One thing that is rather handy and easy to do is to put a grid on your plot. The command is just grid. Now I'll do some customization of the annotations on our plots. It can be handy to use italics, subscripts, superscripts, and Greek letters at times. Luckily, all of that is pretty easy to do. Recall that we use the title command to put a title above our figures, the X label and Y label commands to label the X and Y axes, and the legend command to add a legend. All of these commands accepted strings as their input arguments. There are some codes we can put into these strings to customize them though. To create a superscript, use the caret symbol. This is the same symbol you use for exponentiation. A subscript is denoted by the underscore character. For example, let's take our previous plot and add a title which shows the equation we used. The command would be a title, an open parenthesis, and a single quote to denote the start of a string. Let's let our title be y_1 equals 3, e, a caret symbol, an open curly bracket, -t/2, close curly bracket, cosine of 4t. Now terminate the string with a single quote and close the parentheses. Notice that the curly brackets grouped the -t/2 term so that the subscript operation applied to the entire group. If I'd left off the curly brackets, only the first character after the caret would be subscripted. To add Greek symbols, use a backslash and then a code for the symbol you want. Usually, for Greek letters, the code is just the letter name spelled out phonetically. So let's put a vertical axis label on our plot by typing Y label, open parentheses, quote, this is a Greek letter, colon, space, /beta to put the Greek letter beta there, another quote, and closing the parentheses. Italicizing is done with the code IT. Type a /IT, and the remainder of the string will be italicized. Let's add a label to the x-axis by typing xlabel, parentheses, a quote, here is some, /IT, italicized text, quote, close parentheses. If you want to italicize just a portion of the text, use the curly bracket trick. Let's type xlabel, parentheses, quote, just one, open curly bracket, /IT word, close curly bracket, is italicized, end quote, close parentheses. Italicizing is especially nice in conjunction with Greek letters. It's typical in mathematical expressions to show these symbols in italics. Let's change our title. I'll type title, open parentheses, quote, the letter, curly bracket, /IT, /beta, close curly bracket to end my italicization, is italicized, close quote, close parentheses. We can also use some of our previous knowledge to change the font. Let's use the up arrow to get to our previous title and add a font size code to increase the title font to 16 points. To end this video, I'll talk about putting numbers into our plot annotations. Matlab treats text strings fundamentally differently from numbers, since Matlab's plot annotation functions, such as title, xlabel, ylabel, and so on, expect text strings as their arguments. There's a trick to sneaking numbers into your annotations. Luckily, it's not a very difficult trick. The Matlab function num2string converts numbers to text strings. The command takes a number that's provided as an argument to the command and returns a corresponding string. You can use the resulting strings to display numbers that you calculate in your plots. There's a slight modification that you will need to do when you use the annotation function this way. The argument needs to be defined as an array of concatenated strings. Just put square brackets around a comma delimited list of the strings you want to display. First, I'll create a variable omega equals 2. Now I'll create a function that's based on omega. So new var equals cosine of omega times t data. Now let's create a new figure window and plot the function by typing plot of t data, comma, new var. I'll add a title which includes the value of omega by typing title, open parentheses, open square bracket to denote the beginning of an array, quote, the frequency is, colon, end quote, that's the first string, comma, num2string, the argument for that, which is omega, comma, quote, rad per second. That's our final string. Close square brackets, close parentheses. This trick can be especially useful if you're doing parametric studies where you're creating figures that correspond to the value of some parameter you're varying. You can loop through the values, create your plots automatically, and label them appropriately as they're created. I've introduced a bunch of material related to Matlab's graphics in the last couple of videos, but there's still a lot of other stuff you can do with Matlab's graphics. When I got my first version of Matlab, it came with hard copy documentation. This is the book on using Matlab. This is the book on using Matlab's graphics. Now, Matlab's grown a lot since those days, but I'm betting that there is still almost as much documentation relating to graphics as there is about the rest of Matlab. An important topic that I didn't cover in this video is the concept of handles. All of the components of Matlab's figures have these. By using handles to access the parts of your figures, you can exercise a lot of options that you can't by any other means. For example, the GCA command returns a handle to the current axis properties. This handle allows you to set the tick marks on the axes and the labels of these tick marks, the xtick and xtick label commands I mentioned earlier. I also didn't talk about any of MATLAB's 3D plotting capabilities or MATLAB's ability to create movies from your figures. If you're interested in 3D plots, look up the surf and mesh commands. Movies are easily created with the getFrame command,